IMP, Institute for Material Testing in Switzerland, and he's still owner of that company. Next to that, he is also very active in a lot of other things and in many committees. Christian, the floor is yours.
Thank you, Egbert. Ladies and gentlemen, I'm very happy to present you some results of a huge Swiss research program concerning warm asphalt. We focus today on the mechanical properties and quality control. So the objective of the projects were to assess methods of control on one hand, and on the other hand to study the mechanical behavior of warm asphalt by realization of test sections. You see here the structure of the road. We had a foundation, a lower base layer, and in red letters the upper base layer, and in that layer we changed the mixtures, so we used different mixes to lay the upper base layer, and everything has been covered by a surface layer. The test section, we had each 800 square meters, or 130 tons for each test section, and we think that's big enough to have a continuous laying process. You have here the 5 mixes we chose. First of all, we had reference mixtures produced at 165 degrees, so a hot mix asphalt. And then we had a chemical additive, we call that a chemical package. So the code is PAC, produced at 130 degrees. We had zeolite produced as well as 130 degrees. And we had foam technique at 115 degrees, one time with 50% wrap and one time without wrap. So we ran the laboratory control of the mixtures and of the cores without just any problems. So we can say that the results of the quality control of the late test sections were similar in terms of mix composition, similar in terms of void content of the Marshall sample compacted in the laboratory, and void content of the late mixture in the field. As well, the thickness was comparable, so we can say the test sections were completely comparable, and we can focus on the mechanical properties. Doing that, we had a look to the water sensitivity, to the compactability, the bounding of layer, and to the warm and cold temperature. Let's have a look to the water sensitivity. It's more or less the same than we saw in the previous presentation. We have some problems with the warm mix asphalt to reach the same qualities and we have with a hot mix asphalt. We have here the Swiss requirements, and you see that the reference mix do fulfill the Swiss requirements, and the warm mix asphalt produced with a chemical additive, with zeolite and with water-based foaming technique do not fulfill the requirements. So we can say that the warm asphalt seems to be more sensitive than hot mix asphalt on one hand, but on the other hand you see that the use of wrap can help, because if you introduce wrap in the mixture with the foam technique, we fulfill the requirements. Having a look to the compactability, we used a gyratory compactor according to the European standard 12697 part 31. And on this graph you see that if you want to reach a void content of 10%, you need of course less number of gyration. But you see as well that at 10% of voids you don't realize really big differences between the mixes. But if you rise up the compaction degree, if you reduce the void content, you see that the differences between the mixes become bigger. And you see that for the warm mix asphalt you need less energy to compact them, less energy in comparison with hot mix asphalt on one hand. But you see as well that the use of wrap reduces the effect of foaming in terms of compactability. So it is more difficult to compact a warm mix with 50% of wrap. We had a look to the binding of layer. We drilled cores after 1 day, 2 days, 4 days, after 5 months and after 9 months. The results were not satisfactory, but not only for the warm mix as well for the hot mix asphalt. So we did not know if there was a problem or not. And you can imagine the test section were laid on a public road, And if you say to the authority, I come 5 times and I drill on 5 test sections, each time 4 cores, you get some problems with the authorities. So even if you were in Switzerland, it was not possible to make a Swiss cheese out of the road. And so we did not know if there's a problem or not. And therefore we started a laboratory investigation to have a clear answer. Doing that, we laid a hot mix base layer in the mold of a laboratory compaction, a steel roller section according to part 33. On that base layer we applied different tag code on which we applied upper layers, and we had different upper layers. One was a hot mix asphalt laid at 165 degrees, and 3 were warm mix asphalt, zeolite, chemical additive, and wax laid at 130 degrees. So we tried to reproduce what happens in practice in the laboratory to get an information if there is a problem or not in the binding of the layer. So we drilled core out of the plate after 3 days, 21 days, and after 3 months. And afterwards we ran the bounding test according to part 48. You have the presentation of the results here. What we see is an increase like in practice. You know that if you drill core some days after the laying process, you have usually better results than if you wait some weeks or some months. And in general, we can say that in the laboratory we have the same increase of the values. We see as well that we have good results for all warm mix asphalt. The Swiss requirement is, the Swiss requirement is at 12 kilonewtons. So we can say that under laboratory condition, you can reach good results with warm mix asphalt. However, the best results have been measured with a hot mix asphalt. Having a look to the warm temperature behavior, we ran the triaxial test at 50 degrees, and you have in that slide the rate of deformation, and you see that the reference mix has the lowest rate of deformation. But here we have a look to the penetration of the binder, here introduced in dark blue. You know, if you produce a mixture at a lower temperature, you will get a lower aging of the bitumen, and this is clearly seen in the penetration. So we have, with the reference mixes, a lower rate of deformation on one hand, and on the other hand as well, a lower penetration. But my personal opinion is that the difference in the penetration is not a full explanation for this big difference. Warm asphalt has a bigger deformation than the hot mix asphalt on one hand, and on the other hand, if we compare the mixture at equal penetration, we can say that chemical additive has a lower deformation rate than zeolite, and zeolite are lower than water. And again, we can say the use of wrap can help, because if you use wrap, you have a lower deformation rate. We had a look to the low temperature behavior using the uniaxial test according to part 46 at plus 5 degrees. Maybe you will say plus 5 degrees is not really a low temperature, I agree with you, but in the period October to March, plus 5 degrees, more or less temperature, it's more, we have the most time in Switzerland, and so in the central part of Switzerland. And therefore we choose that temperature. And using the uniaxial tension test, we had absolutely no differences between all the mixtures. So at the end, you can make a spider chart comparing the mixtures, and if you want to focus on warm behavior, you can look which technology may be the best. If you look to another property, you can make your own choice. Let me come to the conclusions. So we had absolutely no problem to run the standard test for the quality control. We had similar results for the laying process and for the compaction. However, we had quite big differences in the mechanical behavior comparing the different methods for warm mix asphalt. Thank you for your attention.